Welcome to Accounting Modeling. In this video, we are going to discuss about another important application of Excel Solver. We call it scheduling of workforce using Excel Solver. So when it comes to this particular application, basically what happens there is you are identifying a particular operation. So for an example, you may identify the check processing of a bank. For that particular task, for a particular period of time, you are going to identify what should be the optimum number of employees that must be there to accomplish the task. For a particular identified task, you are going to decide what should be the minimum number of employees that must be there. Because when it comes to a business organization, they always try to maximize the profit. In order to maximize the profit, the cost need to be minimized. Hence, the organization would love to see that there would be minimum number of employees in order to perform a particular operation. So thereby, their bottom line can be enhanced. If I take another example, so think about the operation of a supermarket. So in the day-to-day activities, we may be going for the supermarket. We are going for the supermarket. And there we see that in the flow area, there are several employees. Several employees are there. So when it comes to that particular supermarket, so they do have to decide for a particular period of time in order to achieve the objective, how many employees that it should be there in the flow area. So depending on their experience, they know what are the peak hours and what are the off peak hours. So depending on that, so considering a particular time period, they should decide what must be the minimal number of employees that must be there to achieve the objective. The objective in the sense they need to ensure that the customers are getting a kind of service. So it's a kind of good service. So in order to ensure the customers are getting a good service, what must be the minimum number of employees that has to be there. So that is another application of this workforce scheduling. So here basically what happens is that so the other roster is decided accordingly. So even you would be having kind of experience that when it comes to a particular audit, so those who are undergoing internship, you may have that particular experience. So there they would decide, so what must be the minimum number of employees that has to be there for that particular audit assignment. So depending on all the assignment for a particular period, they would identify what must be the minimum number of employees that there should be there for a given period in an organization. So likewise, they would plan their number of intern that it has to be there. So these are very practical examples. So in a day-to-day life that you would feel. So in performing such kind of activity, so this Excel solver would make your life pretty easy. So we'll see how to perform such kind of activity using Excel solver. The activity 6. The ABC Bank processes checks in each day in a week. The least number of workers to process checks for each day is shown below. So below gives the minimum number of employees that it has to be there in each day of a particular week in order to perform the checks. So depending on the experience of the bank, so considering the peak days and the off-peak days, they have identified what must be the minimum number of employees that has to be there. So in Monday, in order to perform process these checks, they need 17 employees. Tuesday, 13. Likewise, throughout the week, they have identified the number of employees that it has to be there to process the checks. Then it says all bank employees work for 5 consecutive days. That is in the sense, so if your roster begins on Monday, those employees at a stretch need to go for Friday. Then they can have holidays of Saturday and Sunday. And particular set of employees who starts their work on Tuesday, they may at a stretch go up until Saturday, and Sunday and Monday are their kind of holidays. Similarly, if someone starts on Wednesday, or someone in the sense, a particular group of employees starts on Sunday, where Wednesday, they should go up until like Sunday. Then Monday and Tuesday could be their uh, holidays. So that is what it means. Then it asks, what is the minimum number of employees that the ABC bank should have? Considering this particular operation, what must be the minimum number of employees they should have? So in order to manage this task, so what should be the minimum number? So that's what the question is about. So when you're approaching questions of this nature, you need to ensure that first you are getting the basic model developed. As always, we discuss, you need to develop the model. So in that, we can develop the structure like this. First, you may identify the dates. So there you have from Monday to Sunday. And again, you have to assume a particular roster. Particular roster has to be assumed. So let's say that there are some employees who would start their work on Monday. Say there are like, so indicate that the working days, I might take 1. So if a particular set of employees start their work on Monday, they need to go up until Friday because the bank employees work for 5 consecutive days. So accordingly, I might develop this structure as such. So then Saturday and Sunday, they are off days. And another set of employees who can start their work on Tuesday, then they need to go for like Saturday. Then Sunday and Monday are their holidays. Similarly, there can be some set of employees who would start their work on Wednesday, then they may go for up until Sunday, then Monday and Tuesday could be their holidays. Similarly, there can be some who would start their work on Thursday and they would work until Monday, then this would be their holidays. Then similarly on Friday, those who start on Friday can get then we have on Saturday Sunday is those who start on Sunday, they would take holidays on Friday and Saturday. Right. Now we have developed the kind of roster. Now we may agree or we may get how many number of employees would start their work on Monday. Let's say how many number of employees. How many employees? How many employees starts work how many employees starts work on Monday. Say that there are like 5 employees out of the employees that we have. We assume that 5 would start on Monday, 3 on Wednesday, 4 on uh, when, 3 on Tuesday, 4 on Wednesday, and 6 on Thursday, maybe uh, another 5 on the next day. So likewise I might assume the number, say another 3, another 4, likewise. So I might take Monday, Tuesday, likewise. So Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. So here we have, I have just assumed the 5 employees starts work on Monday, 3 on Tuesday, 4 on Wednesday, 6 on Thursday, 5 on Friday, 3 on Saturday, and 4 on Sunday. So consequently, if I take the total over here, it will show the total number of employees that I may have, that the business organization may have. Here if we get the total, so in this business organization, according to the values that we have assumed, there we have 30 employees. So the total employees is 30. Here it's a kind of assumed figure. Here it comes as 30. But what we need to ensure is that what is the minimum number of employees that the ABC bank should have? In order to perform the check processing, what must be the minimum number that the bank should have? And here we have identified, the bank has identified the minimum number of employees that must be available on each of the date. So therefore, if I take the availability over here, you need to ensure that availability has to be 17, 13 employees is needed on Tuesday, 15 is on Thursday, 17 is needed on Thursday and Friday, 9 needed on Friday, and Saturday we need another 9, Sunday we need 12. So that is the requirement. If we have 17 employees in Monday, that's it. It doesn't matter when they would start the work. It is not the thing that is material. But we need to ensure that in minimum there must be this number of employees in order to perform the task. Then let's see how many employees are actually there. So how you get that? You can simply apply your sum product. Then if you simply multiply it by the number of employees who would start the work by the Monday column, so you would get how many would be there. Here as per our assumption, so this would be the number of employees who would start the work, and the array 2, that is the availability on Monday. So if you get them multiplied, you can see that it comes 23. Since you have made the first column in constant, you can simply drag this. You can simply drag it. Then it will show in each of the day what would be the employees who are. So here it is what we call the available number of employees, isn't it? Available number of employees. And here I would say minimum number of, or the required number of employees. This is what it is required number of employees. So therefore you need to ensure that the availability should always be greater than or equal to the minimum requirement, because you need to ensure at the end of the day, yes, you need to minimize the cost, minimize the number of employees, but you need to make sure that you are efficient, uh, effective as well. So therefore the achievement of the target should also be ensured. So in order to achieve this particular target, you need to minimize the cost. So therefore both the efficiency and effectiveness has to be there. So in fact you can reduce the number. You can even take this to 0, the number of employees. So therefore that would be the most ideal situation, because you don't have to pay anything. But at the end of the day, you can see that the work is not being performed. Work is not being performed. So therefore what you need to achieve is, what is the minimum number of employees that would require to ensure that the work is also performed. Right. Now you are done with the basic structure. Now all what you have to do, you can run the Excel solver and get what must be the minimum number of employees required. Let's go to data, and you can get the solver, and you can say you want to B12, it has already been taken. You don't want to maximize, but you want to minimize. Then how you are going to achieve that? What you can change is the number of employees who would start the work on each day. That's what you can change. So depending on the number you have, you need to plan how many should start the work on each day. So here we have some assumed figures. Now we are going to get this. By changing the number of employees who would start work on each day, you should need to achieve the minimum number of employees. Now you may come to the constraints, starting with add. The first constraint, you need to know these employees, there can't be fractions. The completed units has to be there. So therefore, this changing cells need to be integer. Those has to be integer. So that is something you ensure. You can edit. Then the second condition, the most important one, I would say, the available number of employees must be greater than or equal, to the minimum number. It should be more than the minimum number. If it is less than the minimum number, no, the purpose is not being achieved. So therefore, available number of employees should be greater than or equal to the minimum required number of employees. That would be the second constraint, and those would be the two constraints. You need to make this unconstrained variables non-negative. So here basically that shows that this changing cells is not going to be minus figures if you keep this. So basically we would keep that, and also the relationship that you are going to assume, the independent and dependent variable, that is going to be the simple linear relationship. Simple LP is there. Then if everything is perfect, you can say solve. You can keep the solver answer, and the answer report can be taken. See what has happened. So earlier we have planned for 30 employees. Now the optimum level of employees has come over there. It is like 20 employees. It's like 20 employees is what it takes to perform the particular task. So if you go to the answer report, you can see that original value of the objective was 30. Now it is taken down to 20. If you have 20 employees, you can ensure that this particular task is being performed. And they have identified that on Monday, you need to start 6 employees, Tuesday only 1, Wednesday 1, Thursday 4, Friday 1 employee, Saturday 2, and Sunday 5. And this is basically the roster. So you would have this, and you may assign the employees accordingly. So you would ask the employees, the 6 need to work on Monday, start on Monday, 1 on Tuesday, Wednesday 1, Thursday 4. Likewise, you need to communicate your employees how they need to or when they should start the work. So that is basically their roster. And also you can see that the minimum required is also accomplished. Monday you have 18, so you can manage. Tuesday 15, Wednesday 15. So 15 is required, 15 is there. Thursday 17 required, 17 is there. 9 is required, 13 is there. 9 is required, 9 is there. 12 is required, 13 is there. So if you plan the roster like this, you can see the purpose being achieved. And also you can see the binding and non-binding constraints, available number of employees. It's not binding, not binding, 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 not binding, binding, and not binding. So it is how you work out a question of that nature. So therefore, in a given situation, if you've been given to plan the work schedule or schedule the workforce, so what you need to do, so you need to have a kind of structure like this depending on the requirement. So here it says all employees work for 5 consecutive days, but in a given question would say all employees may work for like 3 consecutive days, then they take a break of 1 day and thereafter they would work the rest of the days. So likewise, according to the policies of the organization, you need to have this particular structure developed, and thereafter you can identify the number of employees over here and then also the minimum required versus the availability. So this is what the structure that you need to know in order to schedule the workforce. Fine. Now let's look at another application of solver, Excel solver. We call it using solver to solve transportation and distribution problems. You know, when it comes to the business organization, this is a kind of main concern. That is in the sense, if you take a kind of manufacturing business organization who distribute their goods to the outlet or the outlet of the different buyers, so you need to come across situation as such. Say for an example that you have your manufacturing facilities throughout the country. Let's say that you have one factory that you operate in Anuradhapura. So therefore you have one plant, manufacturing plant in Anuradhapura. Then another plant, say that you have that in Puttalama. So that is another part of the country. And similarly, you have another plant, say that is in Batiklo, right? So likewise, you can see that, so your manufacturing facilities are in different parts of the world, different parts of the country. So depending on the labor cost, you might have shifted to some of the kind of rural areas where you can have a kind of cost savings. So there you would have to pay less for the employees, so thereby you can make sure that so you are achieving those targets. So likewise, you have kind of manufacturing facilities located in 3 places. And also let's say that you would be distributing these goods to again different parts of the country. Say that you have your own kind of stores in Kurunegala and Colombo, also Galle, Mathura, Kandy. Likewise, you have those your sales outlet in different parts of the country. So in that, what is the main concern is that when you are going to take these goods to these stores that is located in different parts of the country, you need to decide, you need to plan how many units you are going to transport from each of these manufacturing plant to the sales outlet. That is in the sense, you need to decide, when it comes to the Kurunegala store, are you going to take it from where? or how many numbers that you are going to take. Are you going to take it from Puttalama, or are you going to take it from kind of Anuradhapura plant? Likewise, you need to decide, or sometimes it may be a combination. So the some units say that all requirement of this Kurunegala branch is say 10,000 unit. Then out of that, you might take 6,000 from Puttalama and you might take the rest from Anuradhapura. Likewise. So when it comes to Mathura, so you may be taking most of the requirement from Batticaloa. And the sum of the requirement may be fulfilled even using the plant in Puttalama. So likewise, you need to decide that. So if you are going to do this manually, no, it's not going to work. It's just a waste of time. If you are going to plan your transportation manually or distribution manually, it's not going to work. So definitely, in such kind of situation, the solver may come handy. The solver would come handy. So by using the capabilities in your spreadsheet package, using the Excel solver, you can easily get this across a problem of this nature. So let's see that through an example. It says that the Quality Company Limited produces shirts at its Colombo, Mathur and Kandy plants. So in this question, they have their plants in Colombo, Mathur and Kandy. Colombo plant can produce up to 10,000 shirts. The capacity of each of the plant is given. Colombo is capable of producing 10,000 shirts. Mathur can produce up to 12,000. Kandy can produce up to 14,000 in a month. The company must make monthly deliveries to 4 regions. So they may be having their own sales outlet, or sometimes it may be the sales outlet of the different customers. So you need to somehow ensure that at each month you are going to make the deliveries to the east, west, south and north region. And also the requirement of each of these regions are given. The east require 9,000 unit, west require 6,000, south require 6,000 and north require 13,000. Then how you are going to fulfill that particular requirement? So you cannot just say that you are going to take 9,000 to east from the Colombo plant and that's it. For the west, take 6,000 from Mathura, that's it. Kandy, south, take the rest 6,000 in Mathura to south. And from Kandy, deliver the requirement of north. Something as such. You cannot do something like that. So in fact, you can do that, but if you do that, you are not doing that in the cost efficient way, because the delivery charges would be vary. Delivery charges from Colombo to east, Colombo to west, Colombo to south, it would vary. So therefore, you need to know that what is the delivery cost per shirt. Since you are doing shirts, you need to know what is the delivery cost per shirt from each of these plant to each of the region. So here you are given the cost per shirt of producing and delivering shirt to each region from its each plant. From Colombo to east, it takes rupees 5 to deliver that. From Colombo to east, it takes rupees 5 per shirt. From Colombo to west, once you work out, it is 3.5. The Colombo to south, it's 4.2. North, it is 2.2. Likewise, from Mathur to east, Mathur to west, Mathur to south, Mathur to north is given. And also from Kandy to east, Kandy to west, Kandy to south, Kandy to north is given. So therefore, most of the estimation part is done for you. Now what you need to do, how many units should be manufactured in each of the plant while maintaining the demand of each region? In order to satisfy the demand of each region, what must be the number of goods, number of shirts that must be manufactured in each of the plant? So that is the question that you had come across. So this is basically what we call transportation and distribution problems. And it is very much important for a kind of business organization who would involve in delivering the goods for different parts of the country. And especially if you have several plants. If you have one plant, no choice, you need to deliver everything from there. But if you have more than one plant, so probably the cost consideration would come into play. So you need to consider that. So let me initially take the question to an Excel and let's try the things out. Again, as usual, you know, the development of the structure is the most important thing. So you can identify the demands is given. So that would be a kind of important piece of information. So you would get that, the demand. Also, you are given the cost from each of the plant to the kind of region, to each of the plant to the destination. It is also being given. Then you need to decide how many units must be produced in each of the plant while maintaining the demand. So therefore you need to have a structure like this. You have 3 plants and you are distributing to each of the region. Say it's east, west, north and south region you are distributing, and this is it. The structure is something like this. First you need to assume your kind of production in each of the plant, and then we can work out that using our knowledge on Excel solver. Let's say that in the Colombo, the question says that they are capable of producing, the production capacity is 10,000, Mathur 12,000 and Kandy 14,000. So if I take the production capacities, it's like this. I might take it somewhere over here, the production capacity, or the capacity, say capacity. So the capacity is given in each of these. Colombo 10,000. Colombo you can go up to 10,000. Mathur it's 12,000 and Kandy it is 14,000. So depending on that, we may just assume a particular number. Say from Colombo to east, there you want to deliver say 4,000. From Colombo to west, another 3,000. South 2,000. You need not to worry about even the capacity. You may simply work the things out. Just put some numbers as you wish. From Mathur to east, say you're going to deliver 6,000 and it's 1,000, 2,000 and 3,000. Likewise, I'm just assuming certain numbers. From Kandy to east, 3,000, 2,000, 1,000, sorry, 1,000 and it is 1,500 likewise. So here I have just assumed. Now if I take the total in row wise, then I would get what the usage, the capacity is given. Here we have the usage of, or you can say it is the actual production. You know one thing for sure, actual production always need to be less than the capacity. You can't go beyond the capacity. So you are constrained by that. So if you simply take the sum over here, you can see the actual production comes over there. So if I just to develop this constraint, it's like the actual production should always less than or equal should be less than or equal. So that should be the case. That should be the case. Then again, when it comes to the deliveries, you can see that from using the 3 plants, you have delivered to this east region, west region, south region and north region. And you also know what is the demand. Demand must be, so if I take the demand over here, in each of these region, so you need to fulfill that particular demand. Demand has to be fulfilled. So therefore, if I am to take that, this is, here we have the production that we have sent to each of these region from all the 3 plants has eventually sent 13,000 to east, west, likewise we have it. So therefore it's a kind of minimum requirement. We need to ensure that, so what you would send over there, the goods that you send must be greater than or equal to the demand. So it can't be something less than the demand, so it should be something greater than or equal to the demand, greater than or equal to the demand. So here you can say it is the kind of supply, your supply for each of the region. You have supplied 13,000, 6,000, 5,000 and 5,500. So you need to make sure that at the end of the day demand is being met. That is the necessary condition. Then here the most important consideration is the cost. So you know what is the cost to take the things from Colombo to east, Colombo to west. Likewise, the delivery of per unit cost, per delivery of the cost per delivery of 1 unit is given. So from Colombo to east it takes rupees 5 per unit. For 4,000 it's going to be 4,000 into 5, it's 20,000. So Colombo to west, it is 3.5 multiplied by 3,000, you would get the particular cost. So in order to figure out the total delivery cost, total transportation cost, let me say, total transportation cost. So what you can do, you can simply consider the entire thing. You can consider the range and you can do the multiplication. So because you have learned about the sum product, so using your knowledge on sum product, you can work this out easily. So how do you do? You can take this sum product. Then if you look at it in a manual way, at the end of the day, if you want to work out the delivery from Colombo to east, west, south and north, what you need to ensure, the per unit cost need to be multiplied by the number of units that you deliver. Mathara, from each of its regions, the delivery from Mathara, the cost is per unit given. So Mathara, how many units that you sent is also given. So you can simply multiply this Mathara by the number of units that you take from Mathara plant to the different region. Kandy, the same. From Kandy to each of this region that you take, it is there. The per unit cost multiplied by the number of units. So you can achieve everything at once if you select the entire range. You can make it constant if you wish and multiply it by the number of units that you would deliver and make it constant. You can see that under the prevailing condition, the cost has comes as 106,000. And this is what you want to minimize, subject to the given constraint. You need to conscious about the capacity, and also you need to ensure that somehow the demand being, the minimum demand being met. The minimum demand being met. That's it. So let's try to work the things out. You can go to data and you can get the solver. So you want to minimize this by changing what you can plan is the number of units that you are sending from each of the plant. So therefore this is going to be your changing variable. You can plan how many units that you are going to send from each of these plant to each of the region. Then the constraint has to be there. The first constraint, what is that? We have identified the actual production of each of the plant must be less than or equal to the capacity. At any given point in time, you cannot exceed the capacity. It's a constraint. The actual production should be less than or equal to the capacity. And when it comes to the kind of supply and demand, you need to ensure that at the end of the day, you are meeting the demand. The minimum number must be delivered, So therefore, your supply must be kind of greater than or equal to the demand, So that is another constraint. And also the number of units that you deliver, you know that it has to be kind of completed unit. Hence, make sure that this delivery units is integer. So consequently, you have added 3 constraints. The make unconstrained variables non-negative. So your number of units that you deliver can't be negative. So you ensure that. And the relationship you assume always the simple linear relationship. So assuming that, you can solve. Then also take the answer. Say okay. See what has happened. So eventually your production has become equal to the capacity in most of the circumstances, and even below that when come to the candy, and you have fulfilled the demand. As well. See, you can see that the Colombo from Colombo, the entire thing that you sent to the north, 10,000 that you sent to the north, so that gives you a kind of cost saving. From Mathura, you have sent some, that is in the sense 3,000 to west, 6,000 to south, and north another 3,000. So therefore you have utilized the Mathura capacity to its fullest. And Kandy, you are sending 9,000 to the east, you are sending 3,000 to the west. So out of the capacity, you only require 12,000. And when it comes to supply, you can see that at the end of the day, east was sent 9,000 unit, and that was in fact the demand that they had. You have achieved that. West, you had the demand of 6,000, you have ensured it is being achieved at the end of the day. South, there you had 6,000 demand and you have achieved that. The north, yes, 13,000 demand was there. At the end of the day, you have achieved that 13,000. And you can do this at a cost of 86,800. At a cost of 86,800, you can achieve that. So it is about the kind of delivery and transportation handling scenario. So if you are given a question of this nature where the delivery and the transportation is taken into consideration, so what you need to do is you need to have a structure similar to this. So you are given the manufacturing plants, so you need to consider those manufacturing plants, and you need to assess the demand from each of the sales outlet. So those has to be considered, that is the region in this question. So it may be sales outlet. So considering that, so you can work out the kind of combination what match your requirement, what matches your requirement. So you can decide depending on your manufacturing capacities how much that you are sent to each of the regions or each of the sales outlet in order to achieve the end purpose. So it is about the production and it's about the transportation and delivery questions.